M. Manohar Hussain, and co-chairman Dr. V.K. Tripathi, reporter Dr. Amit Kumar to stage and continue the program further.
7 minutes are allocated for his presentation. I invite Sadaf Nazneen to present the paper on spatial variability in the water quality.
Delegates present here and students. I'll be speaking about surface water and specifically wetlands, which form a major part and a very crucial part of our natural water system. So this is part of my PhD work. I worked on Chilika lagoon, and today I'll be presenting on spatial variability of water quality in Chilika lagoon, which lies on the east coast of India. So first let me introduce what lagoons are. Lagoons are basically coastal water bodies which are shallow, and they have narrow connections with the sea on one end, whereas any major river or its tributaries or distributaries join on the other end. So it has a very unique character in the sense, on one side you may find very saline character, on the other end you will find a brackish nature, and at one point there's a fresh water discharge through the rivers. So as I said, they're separated from the ocean by a barrier connected to the ocean by one or more restricted inlets. Everybody knows in today's time land use changes, less fresh water discharge, lots of sedimentation coming through the rivers, and point and non-point sources have started affecting these lagoons. Since these are shallow water bodies, so any change in the connection with the sea or less freshwater inflow can wreak a havoc to the ecosystem. So Chilika was one of the examples where it was first included into designated Ramsar site in 1981. But by 1983 it was included into list of endangered wetlands because of its stressful environment. So many steps were taken later on in 2000, where Chilika Development Authority came up and it took several steps which has now improved the condition of this lagoon, but yet a lot needs to be done, and this is how the regular monitoring of this lagoon needs to be done. Now to speak about Chilika, let me tell you that Chilika is the second largest lagoon in the world. It is a biodiversity hotspot. It harbors many rare and endangered species of plants as well as animals. It supports nearly 1 million bird species, and nearly 2 million fisher folks live in and around Chilika lagoon. Next slide please. So the purpose, as I told you, of this present study is that Chilika was a designated Ramsar site. Later on it degraded due to lots of siltation. Actually the narrow constriction with the sea was choking due to siltation, which led to the decline in salinity. And decline in salinity was converting this lagoon into a freshwater ecosystem. Lots of weed proliferation was taking place. The depth of the lagoon was decreasing due to the siltation, and gradually the fish production and the mollusk as well as prawn production was going down, which was affecting the livelihood of communities living in and around Chilika. Next slide please. This is my study area. Basically we divide Chilika into 4 sectors. You can see here this is connected to the Bay of Bengal. This region, this is the northern region where the distributaries of Mahanadi river join Chilika. So it is more or less, this section is freshwater section. This is highly saline. This is a mixed water section which is known as the central sector, and here this is the southern sector, which is the deepest part of the lagoon, and more or less this is a stable part of the lagoon. Next slide please. So materials and methods, I had collected 26 water samples during the first week of June, which is before the onset of the monsoon. So you can see my sampling is uniform from all the 4 sectors. Next slide please. This was some of the sampling that I did in Chilika lagoon. Next slide. These are some of the parameters that I analyzed in methodology. Next slide. Next slide. First, I would like to discuss the spatial variability of salinity. As you can see in my slide, there's a lots of variability. The minimum was 1.3 PSU, whereas maximum is 32.8. So this is the region where maximum salinity can be observed. This is the freshwater region where the salinity is lowest, whereas these regions show moderate salinity. Next slide, please. pH, as you can observe, this more or less is an alkaline system because of the seawater influence. Most of the part is influenced by seawater, so this is more or less a alkaline system. Next slide, please. Now I want to speak about dissolved organic carbon, because this is one of the very important parameters which is helpful in the sustenance of this ecosystem, because many benthic organisms and plants take carbon in the form of dissolved organic carbon. Previous one. So you see, dissolved organic carbon is generally, it comes from the catchment basin, washed away from the river. So this region shows the maximum concentration of dissolved organic carbon. And also due to the death and decay of macrophytes, this is heavily infested by freshwater weeds. So this region, you see the dissolved organic carbon is high, whereas these regions show lower amount of dissolved organic carbon. Next slide, please. This is dissolved oxygen. The dissolved oxygen concentration is quite high. You can see maximum is 13 mg per liter, which is quite good for an ecosystem. This shows that the productivity, the plants, macrophytes are quite active in this lagoon. This variety of macro and microphytes which produce a good amount of photosynthetic activity is going on, and this lagoon is very rich in dissolved oxygen. Next, please. I had also analyzed nitrate, and you see there are certain pockets where nitrate is very high. And this is basically, there's a temple out here known as Kalijai temple, which is visited by many people during certain seasons, and they discharge this waste and temple waste directly into the lagoon. So this is one of the reasons you see very high nitrate here. Again here, due to the agricultural activities in the fringe parts also, the nitrate values are very high. Next slide, please. Again, the phosphate also in certain pockets, you can see in the northern part and here in these pockets, phosphate values are very high. This is because here there are certain villages on the banks of this lagoon which directly discharge the waste into the lagoon, which is leading to a high amounts of phosphate in certain pockets. Next slide, please. Dissolved silica. This is again basically it comes from the catchment. Dissolved silica. So,
Nazneen, kindly.
Okay. Next slide, please. Yeah, just next slide. What we see in this lagoon is that the water quality at present is good because there was a dredging activity happening. The connection with the sea was increased in 2000. The connectivity was made better, due to which salinity increased. And we see that again the lagoon is in a good condition. It is a well mixed and well oxygenated lagoons, but there are pockets where nitrate and phosphate levels are high, which needs to be checked, probably due to the flow of agricultural waste as well as direct household waste into this lagoon.